Okay. All right, I was hearing a lot of responses, and I heard a very quick, short, either no or yes for the answer for number 1 and 2. So let's see, Vince, what'd you say for number 1? Is 3 negative 4 a solution to that equation?
No.
No. How did you know?
You plug them in.
You plug them in for x and y, right? And 3 squared plus negative 4 squared does not equal 36. Excellent. And then, Garrett, what did you say for the second one?
Yeah.
Yes. What did you do to determine the answer was yes there?
Well, I plugged it in, and then 25 is less.
Excellent. 9 plus 16 gave him 25, and that is less than or equal to 36. Check. So what you might be noticing here is so far in Chapter 5, we've been looking at systems of equations, equal signs, like seeing what x, y, or what x, y, and z works for all equations. Well, now we're going to be looking at systems of inequalities. Those are your less than, or your greater than, or your less than or equal to, or greater than or equal to symbols. And what you have to recognize is that we are now looking at many, many more solutions than just an xy point. In fact, if I was looking for what are all the possible xy values that work for this inequality, technically I would have to graph this. What type of graph would this create? X squared plus y squared. It would create a circle. What would be my center? Yep, would be 0, 0, because remember the equation for a circle is x minus h squared plus y minus k squared is equal to my radius squared, where h and k are my center value. So since there's nothing been subtracting from the x and nothing that has been subtracted from the y, that's where we get that center as 0, 0. And then the radius for this particular problem, we would take the square root of 36. So what would that be? 6. So if I potentially graphed this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, I would have 0, 0 as my center, and then I would have that circular graph all the way around. But now I have to take into consideration, well, let's just look at this point even, 3, negative 4. If I look at 3, negative 4, 1, 2, 3, down negative 4, I can see, yes, this point indeed is less than or equal to 36. And specifically, every single point on the outside edge of the circle, they have a radius of 6, so they all would fit the exact equation. But since this is a less than or equal to symbol, every point inside and equal to, so on the rim of the circle, would satisfy this inequality. So what is my full xy solutions to this inequality? It would be everything shaded inside the circle and on the circle. And so like if, for example, I'd say x squared plus y squared is less than or equal to 36, my answers would lie in the shaded region. So we can even just say that. Answers shaded. And I know that you guys learned about inequalities and how to shade in Algebra 1, but let's just go ahead and create a key off to the side just to kind of revisit. What do those little less than, greater than, how does that help me when I'm looking at a shaded area? Because it will help when we start combining two inequalities and seeing where are all the ordered pairs that fit both of them. So here's kind of like our key off to the side. If you have a less than or greater than symbol, then you're going to have a dashed boundary line, and we'll look at what that looks like in a moment. But it's going to be a dashed boundary line. If you have a less than or equal to or greater than or equal to, how do you think that will change? There'll be a solid boundary line, solid boundary line. If you have a less than or equal to symbol, you're going to shade below. And if you have a greater than or equal to, you're going to shade above. I know you guys learned that, but it might be a while since you've seen that, so just to kind of revisit, how do we look at shading answers to inequalities? Okay, now that we have that little key off to the side, let's use it for different types of graphs we've looked at with college algebra. So, again, for an equation, the solution must lie on the graph, just like the solution here would have to lie on the circle if it was an equal sign. But for an inequality, the solution point must fall in a certain region of the graph. So let's take a look at these regions, what we should shade. Sketch the solution for the inequalities below. Y is greater than or equal to x squared. So I want to envision this as y equals x squared. I know the parent graph for that. That has an ordered pair at 0, 0. It has points at like 1, 1, negative 1, 1, and then I can just kind of increase steadily. Now this less than or equal to, should I have a dashed parabola or a solid parabola? Solid parabola. That's why I just went ahead and bolded in my curves. And then should I shade above or below? Above. So I would go ahead and shade above my graph, and that means every point within that region should be an answer to this inequality. And we could check, for example, I could check the point 0, 2. When x is 0 and y is 2, does that work? Is 0 truly less than or equal to 2? Yes, so I know I have the right area shaded. Okay, y is less than or equal to x squared. Again, I'm going to have a solid boundary line, but this time, instead of shading above, what should I shade? Below, exactly right. Shade below. So I have that graph. Now it did say sketch, so I don't have to be very particular about my points, but I do want to make sure that I have at least a good sketch. So I'd shade everything below. Okay, what if its y is greater than x squared? How would I have a dashed or a solid boundary line? Dashed, and again I'm going to shade above. Shade above. So I have that dashed line instead of the solid line going up. And shade above here. And then just to really drive this point home, if we choose a point that's actually on the dashed line, we want to make sure we know why it's dashed. For example, this point 1, 1, it has to be dashed because I want to show that 1, 1 is not a solution. Why is it not a solution? Because 1 is not greater than 1 squared. It's equal to 1 squared, which means I have to have that dashed boundary line to show that all these points along the actual curved shape do not exist as solutions. Okay, and last but not least, y is less than x squared. Would it be a dashed or a solid boundary line? Dashed, and how would I shade? Good, shade below. All right, that was a quick kind of 8-ish minute review. Now we want to extend this to chapter 5 of college algebra. And we're looking for where is the answer to a system of inequalities? So when I bring two equations together, I'm going to be looking for the overlapping solution area. But just to make sure that we are good with shading before we jump into that, with your partner, if you could sketch the graph of both of these examples, we'll check our answer and then we'll go ahead and solve some of the newer problems. All right, guys, go ahead and check your answers here. I was playing around with my pen to see kind of what would, because we're going to be shading a lot, so I was going to have a blue and a red pen, and I'm going to see if they're going to come together to make purple. But a few things to check with as far as your lines is, did you remember to flip the sign in the second example? Why did we have to flip the inequality symbol? Because you divided by a negative, and that will come into play with inequalities, so make sure you remember that rule, and then check to see that you have a solid line and you've shaded above. Jeremiah.
For the first one?
Yeah.
So that's shading above, like, why is it all around?
Because in a circle, when we think of above, we really have to think of on the outside because all the outside solutions will fit. For example, if I take a look at, so even though this is not above, this example, or this answer here, 0, -5, it does work because 0 squared plus -5 squared is greater than 9. So I just have to, instead of a circle, and some of these equations are going to be a little bit tricky. You want to think above, what does that mean? It just means everything for a circle on the outside. Good question, though. All right, guys, let's move into the new material then. Now, sketch the graph for the solutions to the following systems of inequalities. Example 1, this problem you should be able to graph by hand because you have studied both of these graphs. When you're solving, here's some kind of steps of action for you to pay attention to. 1, you want to see if the two equations intersect because that's going to help you kind of visit what points are important points of the graph. So step 1 is going to be find the intersection of the two equations to see will they touch. Step 2 is going to be to sketch the two equations, so if there was an equal sign. And then you're going to shade the regions based off of our key, based off of what you know for inequalities, and then darken the final solution where they overlap. So how do we find the point of intersection? You set the two equations equal. So for example, I'm going to see where does x plus 2 squared, where does it equal -2x squared? Or I could say, will it equal that? Because it's possible the curves won't intersect. So if I multiply this out, I would have x squared plus 4x plus 4. And I'm asking, where does this equal -2x squared? How would we go about solving that then? Add 2x squared, we would have 3x squared plus 4x plus 4 is equal to 0. Does this, or how would I solve this? It's not factorable, so what do we do if it's not factorable? Quadratic formula, so x equals the opposite of b, plus or minus square root of b squared, so what's 4 squared? 16 minus 4 times 3 times c times 4, all over 2 times the value of a. Now something I noticed right off the bat here, -4 times 3 is -12. -12 times 4 is a -48. What does that mean that's going to happen underneath the radical? It's going to be a negative. So what happens when we have the square root of a negative? Yes, it's an imaginary number. So what does that mean about these two graphs? Should they intersect? No. Now if I actually simplified this out, let's see, that'd be 16 minus 48. What is that? -32, just so you know. But realistically, it's going to be an imaginary solution. Therefore, they will not intersect. So I'm just going to have a bunch of shaded places. No real important points of where they're going to come together. So x plus 2 squared, we know how to graph this. How would we graph that? What does that plus 2 on the inside of the parentheses do to the apparent graph? Moves it left 2. Good. So I'm going to move it left 2 spaces. It's a less than or equal to symbol. So am I going to have a solid or a dashed boundary line? Solid. So I can go up 1, right 1, up 1, left 1. And I have that solid boundary line. And then should I shade below or above this graph? Below. So I'm going to go ahead and shade this below. And then looking at my next graph, -2x squared. Is this moving to the left or to the right at all? Nope, not moving up or down either. But what does the negative symbol do to it? Reflect upside down. What does the 2 do to the graph? Makes it more narrower, right? So if I have 0, 0, instead of going up 1, right 1, I would go up 2 into the right 1, up 2 into the left 1. And then is this going to be a dashed or a boundary line? Or dashed or a solid, sorry. Solid, thank you. You're like, it's going to be a boundary line, yeah. So I draw that solid. And then how would I shade? This says y is greater than. Shade above, good. So if I shade this above, I have everything here. And where is my answers? Where they intersect, right? So my answers are what x, y values make both of these equations true. So I tried to use like a blue and a red pen to see how they should come together to be purple if I had shaded very well. So my answers are where the regions overlap. So here would be where my answers lie. Any questions on that? Technically everywhere in this case, yes. All right, go. Inside of where? Oh, you're right. So realistically, I should erase this part because the answer for the blue should be everything below. But I do have to erase that here because it's not within the red region. Because for the red region answers, it has to be everything above the graph. So I should realistically have nothing shaded on the inside of the downward parabola or the inside of the upward parabola. Thank you for clarifying that. All right, let's flip to the next one. Example 2. Now, some of these problems you might need to use your calculator just if it's not a graph that we've learned in the past. Keenan, question? Yes. All right, so taking a look at this graph here, this first graph, do we know how to graph x plus y is less than or equal to 9? Yeah, what type of graph should it make? A line, good. So we would just solve for y. We'd have y is less than or equal to negative x plus 9. So I could go ahead and even graph that. The y-intercept is going to be 9, so sorry, we're going to have to go up a little bit off the graph. The slope is negative 1, so we can go down 1 to the right 1, 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 right 1, right 1. There's my graph. It should be a solid boundary line, and I should be shading below. Now this one here, this is one you might need to use your calculator just to be a little bit more, because we're not quite familiar with this graph. So what would I have to do with this before I can use my calculator? Can I enter in anything for x on my calculator? No, we've got to solve it for y, right? So we would divide by negative 1. What happens when we divide by a negative in an inequality? Flips the sign. So we have negative x is going to be greater than y squared. And then what do we do if we have y squared? Square root. So we take the square root, and what do we need to keep in mind when we take the square root? Plus or minus. So we're going to have y has to be less than the positive square root of negative x, and y has to be less than the opposite of the square root of negative x. Now I know we have dealt with the square root of x before, but it is okay to reach for your calculator just if you don't quite remember. But looking at the square root of x, do you guys remember that it's going to look like this? What do you think the negative on the inside is going to do to it? It's going to be reflected over the y-axis? The negative on the inside? No, because you want to think of it as if it's in parentheses. That's inside the function. Ah, but yes, Charlie, you're right. For the second one, this one here, the double negative, Charlie's right in the fact that it would flip over the origin. Why? Because the negative on the inside means it's going to reflect over the y-axis, and the negative on the outside means it's going to flip over the x-axis. So it's actually going to be, we could see that as an origin flip. So if I looked at what this graph should look like, we can confirm this on our calculator, but it's actually going to look like this. But remember, you could see that on your calculator, but just by doing y equals square root of negative x. And then remember, we can do the opposite of y1 on our calculator and graph just to confirm that. But we would see that confirmed. Now the less than symbol, how is that going to change the boundary line? Make it dashed. So I'm going to have a dashed line through this And then this piece as well. And it's less than, so where am I going to shade? Inside. Good, I love that. So below and above, it's kind of hard to think of it when you have graphs in the way that we've seen in college algebra. So in this case, we're looking inside the function. What can you do if you're like, you know what, I'm unsure. I don't know if it's outside or inside.
Plug in a point.
Plug in a point, exactly. So if I'm like, well, does this point work? -3, 0. I can see in my equation, if I plug in -3 for x, does that come out to be less than if I plug in 0 for y? Is -3 less than 0? Yep. So that means this point should be shaded. So I can go ahead and shade this piece in here. Thought that I could. And shade that in. Now, if you're on the surface, which most of you are doing your homework on the surface tonight, what piece should you, what would be my answer here? Everything where? Inside the parabola shape, right? The square root shape. Because it's the overlapping region. It's what xy values work for both equation or both inequalities. So technically, I could erase my blue pieces here and say my answer lies within here. That would be the area of overlap. Any questions on that? Jeremiah?
So we just throwing on the graph, we need to like save this.
You could just erase it, but sometimes people work on paper and they've got shading all over the place. So if you're working on paper and you haven't erased your shading, you just have to mark where your answers would lie. Good question. All right. This next one, what I would like you to do is work on this with your partner, and we'll come together and we'll check our answers. Okay? But on this type of a question on the test, I'd ask you to label the points of intersection. So you want to be able to make sure that you can do that by hand. So maybe check to see, do I know that finding the points of intersection would mean set these equations equal to each other, solve for x. So I find that these two equations, well, they're inequalities, but they have two places of intersection, at -2 and +2. How do I find the correlating y value? Well, since they intersect, they're going to have that same x value. So you could plug it into either inequality and see what comes out as y. So I've graphed my line, and I have -2, -1, and 2, 3. And I know these two places are going to be where the functions will cross. Now I saw a few of you have the second equation, the parabola, graphed. Can someone tell me how did you graph it? Did you do it without a calculator or with a calculator? Vince, I saw yours graphed. Did you do it with a calculator or without?
Without.
Without. How'd you do it?
I just kind of eyeballed it.
You kind of eyeballed it?
Yeah.
So you just.
But with the points of intersection, you can kind of just do that.
You kind of saw. Where was your vertex at?
You could probably plug in 0 and figure it out.
So if I plug in 0, I would get -3. So I know -3 is here. Do you guys remember the formula for how to find the vertex of a parabola? If it's in this form, standard form? No, use the calculator? No, it's good. Sometimes we can use this on the calculator, but we did actually learn how to do this by hand, this one. Yes, Alex, good memory. Do you guys remember the vertex is at -b/2a? And then whatever the corresponding y value is? Yeah, f at -b/2a? Parabolas always show up on like ACTs, SATs. So if you remember that, great, and you could figure out what the vertex would be. You could even, do you guys remember how we could complete the square? Do you guys remember taking half of the middle term and squaring it? So if this middle term is 1, I would take 1/2 and square it, add 1/4, and I have to subtract 1/4 on the over here to keep it balanced.
Oh, yeah.
This is all just review just because the final's coming up. You could have used a calculator for this. But this would be y is greater than x plus 1/2 squared minus 3 1/4, so you could say minus 3.25. Now, do you guys remember this is vertex form? Or if you didn't remember that, you could use your transformation knowledge. This graph is going to move right 1/2 and down 3.25 units. Do you guys remember that a little bit? So the vertex should actually be at 0.5, negative 3.25. So Vince, that was a great estimate, right around 0, negative 3. But if we want to kind of be more exact here, that's where our vertex would lie, at 1/2, 3.25, or 3 1/4. Negative 3 1/4. And now we just have that parabola shape. It should be, let's see, it should be dashed. And I know that I have those 2 points of intersection, so I can go ahead and just make it symmetrical up through those points. And now the new material of chapter 5, realistically in 5.5, is where is your solution set to these inequalities? So where would it lie? What is both less than or equal to x plus 1 and greater than the parabola? Where would my solutions lie? Now, if ever you're not sure, just shade them one at a time. Shade less than here, less than the x plus 1, greater than the parabola, so that would meet inside here. Wait, greater than the parabola. Yeah, that's right? Yes. Inside here. And then where would the regions intersect? Where would they overlap? Right in the middle. So then I could erase kind of both pieces once I see, okay, I know where they are going to cross, and there would be my answer there. Now, how could I check to make sure, do I really have good shading, good answers? Plug a point in, like 0, 0. So if I plug in 0 into the first inequality, yes, 1 is greater than or equal to 0. If I plug it into the second inequality, negative 3 is less than 0. So check. I have the right region shaded. Nate.
So our vertex is 3.25.
Negative 1/2, 3.25. Sorry.
Oh.
Wait.
No, yeah, you have it written right. I just.
Yeah, but then I moved it wrong.
Yeah.
You're right. Grr. Left 1/2, down 3 1/4. So yes, I apologize. That vertex should actually be, that's why it felt a little funny to graph. Should be negative 1/2, down 3 1/4 right here. So it should actually be dashed more in that way. Sorry about that. Thank you for clarifying that. Oh, there we go. Because there's our vertex. Left 1/2, down 3 1/4. Alex. So the test will be just as you guys have had in the past, calculator and non-calculator. So you want to make sure that you are able to, like graphs that you've seen before, like you should know most things to know about a parabola. You should know about a line. Square roots, it's been a while since we've seen them, but you know, it should be easier to figure out. So what I would do with your homework tonight is try it without a calculator and then say what graphs maybe have I not seen that I would have to use a calculator. Does that help? Yeah. Okay. All right, we have about 4 minutes. Why don't you guys try this one on your own, and then we'll check it.